Hello, welcome to the second Java tutorial. In this tutorial we're going to learn how to make linked lists. What is a linked list? And how is it different from an array? Arrays are fixed in size, so if you initialize an array of 5 elements, the array can't get bigger or smaller. If you want to resize the array, let's say you're adding some items to a list and the list gets full, you need to make the array bigger. Then you need to reinitialize the array and copy all of the elements of the old array into the new larger array. This does work, but the downside is that resizing the array is extremely time consuming, especially when you reach a large size. So if you have 1,000 elements in an array and you want to add 1001, you need to reallocate the entire array and copy 1,000 pieces of memory into the new array. And that'll take a very long time. The alternative approach is to create what's known as a linked list. Linked lists work with references, so each little link in the list has a reference to the next element, which makes inserting and deleting elements from a linked list very fast. However, iterating over a linked list can take a little longer than over an array because you're doing some dereferencing. Also, searching a linked list will take a lot longer, but that's okay because, especially if you have an ordered linked list, ordered arrays you can search very fast with like logarithmic complexity. Linked lists take a lot longer to search. You can't have a logarithmic search of a linked list. So there's advantages and disadvantages to a linked list and array, and they're very different. But I'm going to make a quick example of a linked list and explain it as I go. So linked list example will be the name of my class. And the program entry point will be here. Okay, I'm going to save that. There we go, let's compile that. And run it. I haven't written that. Oops, I haven't written the linked list yet. Okay, that works. I really don't like this color scheme. How the hell do I change it? Somewhere here, I think. View, change color scheme. Default, that's much better. Okay, new file, this will be the linked list class. And for the sake of simplicity, this linked list is only going to be able to store integers. If you're going to implement a real linked list, you probably want to use templates. There we go. And I'm going to give it a constructor. Not entirely sure. Yes, and we're going to have to make another class called link. Okay, so a link will have two pieces of information in it. Remember, we're making a list of arrays, so each link will need to store the... I'm sorry, I just said something wrong. We're making a list of integers. So each link will have to store the integer that it points to. Each link contains one little piece of data, so if you have a list of integers, say 10, you'll have 10 links with 10 pieces of integer data inside them. And the other thing that every link needs is a pointer to the next link. And I'm going to do setters and getters for both of these pieces of data. Or I might not bother with setters. I'll need a setter for the link, I think. I'm not sure. But the setter for data it may be okay just to have that in the constructor, as you'll see. So I'm making two methods here, get data, get next. They'll just return their corresponding variables, which I've defined up here. And let's leave it like that. And here I'm going to put the constructor public link. So you can initialize a link with some data. This dot data equals data, with this data referring to this and this data variable referring to this. So we're assigning a value of data to data. Okay, so that should do it. So a linked list will have a start and or a head and a tail. A start and a finish, head and a tail. The head is the first link, the tail is the last link. And public link, no, public void to, no. I think this is how you do operator overrides. You can override the toString method of any class, so that you can print it to the terminal. So this is just so that we can display the list. First we have to check if the next value inside here is equal to null. If it is, that means that this link is at the end of the list. So then we'll just do return data plus full stop. But if it isn't the end of the list, then we will return, this is returning a string as a sort of, it's returning the link as a sort of comma separated array of integer values. This will make sense. So this is the toString method, which will do some stuff that might not make entire sense to you right now, but you'll see how this comes together at the end. This is the constructor, which initializes the link with a piece of data. Here we have the getters, and here we have our variables. One last method we need to do, which I think I vaguely mentioned, very vaguely mentioned, is a setter for the next, set next, link next. And that will just be this dot next is equal to next. In fact, I will also have a set data, because it's good to have it. It makes sense. And that will be what's in this constructor. And in this constructor, rather than doing that, I'll just do set data to data. It's more consistent that way. The constructor can be the last thing. So we have our getters and our setters directly underneath, and that's nice and ordered. Okay, so hang on, the constructor's in the wrong place. I meant to put it. Okay, that's fine. The order doesn't matter. I'm being really pedantic. Okay, so here we have our linked list, and I'm going to have two methods here: a toString and a add data. So firstly, I'm going to do the toString. And I changed my mind. We are not going to be doing that. We are just going to be doing this. We don't need the tail or the head. We just need to know the first element of the link, and that's what I'm going to store. So this is going to return link.toString. And what does link.toString do? It will do this piece of code here. And you'll see how that works in a second. We can leave this blank, and here we will have one more method, public void add data, int data. If link is equal to null, we need to have this here. Because when the list is empty, link will be equal to null. Once we have our first element in, it won't be equal to null, so we have to do something else. If link is equal to null, then we will do link equals new link data. So it will initialize a new link object with the data set to whatever is provided by this argument here. But if link is not equal to null, then link last is equal to then we have to do some iteration. Get next is not equal to null. Will this make sense, I wonder? I'll explain it once I've written it. Last dot set next. Oh my god. No, last is equal to last dot get next. So this while loop will iterate over the next. It'll iterate over the links until it gets the last link in the list. And then once we have the last element, we will do last dot set next new link data. I reckon that'll do it. So now I'm going to test this out. I'm going to make a new linked list. Call it something stupid. My list dot add data. Put some values in there. This should do it. And the last thing we're going to do is print out the list. So we just do system.out.println my list. If I've done everything correctly, then this should compile. I'd be surprised if I haven't made a mistake somewhere because I've been typing it really fast. Come on, why isn't this auto-completing? Am I being silly? Oh, meant to do Java C. Hey, I made a mistake. The variable mylist might not have been initialized. That's very true. It has not been initialized. Oh. Okay, let's try that. Okay, small amount of errors. ToString and linked list cannot override ToString. Did I not specify it as an override? No, I didn't. So I should have done. What else is wrong? Public string ToString. Oh my god. Rookie mistake. Can't read that. Cannot find a symbol stirring. Yes, I should spell string correctly. And the other error is new link. Yes, there is a missing space here. Okay, there we go. That compiles. Will it run? That didn't work as I wanted it to. So the first element is correct. Link dot plus next dot to string. There we go. Oh, I forgot to compile it. Did I? I compiled it. That should work. That is bizarre. But I only... Okay, if we recompile everything and run that, that should work. Yeah, that worked. I just hadn't recompiled the link Java file. I only recompiled the main class. So this is the list being displayed as I've written it. So what's going on? I'll try and explain it as best as I can. Linked lists have two pieces of data. Each link inside a linked list has two pieces of data, as I mentioned before. The data which is part of the index, if you will, and a pointer to the next link in the list. The reason it's called a linked list is because it's kind of like a chain of links. You know, if you've ever seen a chain, it's made of a whole bunch of different links, and that's how linked lists work. Each link points to the next one. So in our link class, we have two pieces of data. You know, the data that it's storing and the pointer to the next link. If the pointer to the next link is null, you know, a null pointer, that means that there is no next link. That means this is the end. So when we stringify a link, if it's the end of the list, we put a full stop at the end, and here you'll see there's a full stop. But if it isn't the end of the list, then we return our value, a comma, and the next value. And that next value will call this exact same method on the next class here, and then put a comma and call the exact same method on the next class. It's what's called a recursive function. There are problems with using recursive functions, such as Stack Overflow, but that was just a quick, shoddy implementation I did. You know, you can achieve the same effect with iteration. I like recursion. It's cool, and it just seemed like the right thing to do for this demonstration. So why linked list is good? It's really fast to insert stuff and remove stuff. Although when I insert things here in this particular implementation, this add data, I have a while loop. I have some iterations. So the complexity of inserting data is n, where n is the number of links in the list. This needn't be the case. In fact, it shouldn't be the case. You can greatly increase the speed of adding elements if you keep track of the tail, the head and the tail. So I can improve that right now. So if head is equal to null, head is equal to new link, and so if head is equal to null, that means the list is empty. If the first element doesn't exist, that means the last element also doesn't exist. It means that, you know, there's nothing in the list. So we say that the head is equal to new link and the tail is equal to head. Okay, so now they're both the same thing. Else, okay, when we're adding an element, head dot set next new link data. That greatly improves the speed of inserting elements. Okay, so if we recompile that, I'm just going to use a wildcard. Please tell me I didn't make a mistake. Cannot find symbol link. I'm being an idiot. Head.toString. There we go. There we go. And if we run that, runs does not run. Oh, what did I do wrong? Oh, tail.set next. Up. Oh. Made another mistake, and you probably see what I'm doing wrong, because you're not stupid like me. Got it. So we make a new link, and then we say that the tail dot set next. So we say that the thing that comes after the tail is the link, right? Because it's the last thing in the list. And then we say tail equals link. That's what we want to do. So because it becomes the new tail, right? The tail is supposed to represent the last element of the list, right? So we can quickly insert to the tail, but of course, once we've inserted at the tail, there is now a new tail. So tail is equal to link, and that will fix it. And that makes insertion really quick. That makes insertion n1 complexity. There's no iteration there, right? It may still be slightly slower than inserting into a normal array, but it will never fill up. You will always have room. You can insert lots of elements into the list, and it will compile everything and run it, and it will work. It's great. Calculating the length of a linked list, you can store it and increase the length. You can store it so you can say int length, and then increase the length. You can do that, or you can iterate over the array to calculate the length. Iteration will be very slow, obviously. There's tons of stuff you can do with this. So yeah, I think that's it as far as linked lists are concerned. That's how they work.